In a review of security in SQL Server 2016, we'll start with row-level security, a new feature of SQL Server 2016. This predicate-based access control enables the development of databases to use a table-valued function or functions to control access. This affects inserts, updates, deletes, as well as selects. Always Encrypted, another new feature, enables operations to be performed on encrypted data. The data is encrypted from the database to the application with the use of a key. This key can be stored in the consumer's trusted domain. Dynamic data masking, even though it's not really a security feature, it does provide security to control the display or formatting of the data returned from the database. This sensitive data is masked to some user during reads, but can be updated as regular text. There is a minimal impact to performance using this new feature. With any new features inside of SQL Server, there are always new permissions, and that's the case with SQL Server 2016. Included are the above options for row-level security, data masking, as well as encrypted options, and a few others. Transparent Data Encryption, or TDE feature, has been enhanced to support better acceleration of performance. This helps to reduce the overhead of CPUs. TDE has been in previous versions. Credentials are also able to be scoped at the database level in addition to the instance level. As far as the enhancements with row-level security, SQL Server 2016, this feature provides table row access based on a predicate. The context is of the user's credentials querying the data. This ensures a user can only see the data he or she has permission to view. Because it is predicate based on the table, all queries are affected. Select, insert, update, and delete. This can be data related to their department or a patient's that are only assigned to a particular nurse or doctor. Filtered-based predicates affect select, update, and delete. It is referred to as silently filtered because the rows are not returned and there's no indication given that the rows are filtered. It just displays that way. On the other hand, block predicates will return an error or message if there's a violation of the block predicate. The predicate is in a table value function or functions, so the logic is actually stored in the database. This enables the application code to be free from logic to restrict rows. The data is now more reliable and less surface area for the application developer. Even though the predicate restricts the selection of data or updating the rows failing the validation, the user can, in certain cases, update a viewable row that makes it now non-viewable. The predicate is used on all DDL statements: select, insert, updates, and deletes. So let's talk about the filtered predicate. This term, silent filter, means there's no indication that a filter was applied. The security is transparent to the user and application. If no rows satisfy the security, a null record set will be returned. Records that do not satisfy the predicate are excluded and the system continues operation. There's no delay or error message to handle. The predicate can be as simple in the table valued function as where sales rep name, a column in the table, equals a current user of the system, or a group like region of the United States. So it can be granular or summary levels. More complicated logic can be used that includes a join in the table value function that's part of the predicate. This is useful to filter rows on one table that is related to another that actually has the predicate, like a region or a group of users. The application will not know if rows were filtered, so no additional logic is required on that side. If all rows are filtered by the predicate, a null record or dataset is returned, and this can be confusing, so the application does need to know this sort of case. Defining a security policy like this filters rows in a table. Because the application is unaware and that the rows have been filtered, the select, update, or delete operations, including situations where all rows have been filtered out, need to be handled. The application can insert rows regardless of whether or not the filter is applied to the data being inserted into the table. Block predicates are a little different than the predecessor. They affect write operations like update and delete, even though a select is needed to retrieve the data for the update or delete. The block predicate will fail with operation and error message. The application will have to handle the return error to the user. Filtered functions are changeable, and this includes the after insert and after update predicates. These can prevent users from updating rows to values that violate the predicate. Before update predicate prevents users from updating rows that currently violate the predicate, and before delete blocks the delete operations before an actual delete happens. That's where the where clause comes in. An example of a block predicate can stop a user from updating, say, someone's salary to $120,000 if the predicate does not let salaries above $100,000. But the same user can update employee information, like change the last name of the employee where the employee's salary is already above $120,000. So block predicates for update are split into separate operations, before and after. You cannot, for example, block users from updating a row to have a higher value than the current one. This logic is required. You must use triggers with the deleted and inserted intermediate tables in the trigger to reference both new and old values to be handled by the tabled value function. Schema binding can be used inside the security policy. You may define a predicate function that joins with another table or invokes a tabled function. If the security policy is created with schema binding equals on, then the join or function is accessible from the query and works as expected without any additional permission checks. On the other hand, if the security policy is created with schema binding equal off, then the user will need both select or execute permission on these additional tables and functions in order for the query to target the particular table. You may define a predicate function that joins with another table and/or invokes a function or functions. The join or function is accessible from the query and works as expected without any additional permission checks. There are restrictions for row-level security. If the DB user, a member of the DB owner role, or the table owner queries a table that has a security policy defined and enabled, the rows are filtered or blocked as defined by the security policy. Attempts to alter the schema of the table bound by a schema-bound security policy will result in an error. However, the columns not referenced by the predicate can be altered. Attempts to add a predicate on a table that already has one defined for a specific operation, whether or not it's enabled or disabled, results in an error, and the application will have to handle that error. For schema-bound security policies, attempts to modify a function used as a predicate on a table-valued function, within that security policy will result in an error. So changes to the schema are important to watch when doing schema binding as well as row-level security. A lot will have to be prepared for in DevOps in order to make this change. But defining active security policies that contain non-overlapping predicate does indeed succeed. For the row level security demonstration, we're going to open up SQL Server Management Studio 2016 and run a script. Once SQL Server Management Studio is up, we're going to connect to our 2016 instance and open a solution. This solution has a set of scripts for this demonstration. I'll open the first one, row level security, and the very first part is going to go into a specific database called small DW. Give us a little more room on the bottom so we can see the different scripts. The first one is going to create a table called employee with an ID name and a territory ID. We're going to insert two rows, one for territory 1 user and one for territory 2 user. These are SQL Server users. Now, in that database, we're going to create a separate schema called security so we can separate these objects from our database objects. The next is we're going to create this table value function that is needed for row level security. Create for function security schema dot customer access. It's going to pass in a territory ID and it returns a table. And with schema binding, so we lock it in so people can't change the structure of the database. And what it's going to return is a select one, so just to see if there's an actual row from employee where either the username equals the username in the database of the person logged in, or the territory ID passed is valid for a particular row in the employee table. Remember, we put 2 in there, territory 1, territory 2. Also, we're going to say or is member of a DB owner equals 1. So that way, if the person's security is DB owner on the table, it'll let them see the data. We're really doing that so we can look at this demonstration. Because I'm going to insert into this customer table, this into small DW DBO from an existing table, just to get a list of customers. It's also going to give me that territory ID. Now, I must select star from customer to show you that there is data in that table. And they have various territory IDs, our last column. Now, if I didn't have that DB owner in there, once I add this security policy, I would not be able to see any of the data because my username doesn't match a username in that employee table. And that's why we added the DB owner for this demonstration. But you don't have to do that. If you want to lock particular DBAs out of seeing the data, you can do that as well. But here, we're going to create a security policy in the security schema called Customer Access Policy. The filter predicate and the block predicate are the same. They're going to launch the table value function, Customer Access, passing in the territory ID on the table DBO customer. Once we have that created, I'm going to go ahead and look at my customer table, and I can see all the data, and I can see there's territory greater than 1. I'm going to copy this script, and I'm going to open up a new window. So I'm going to connect Database Engine and change it to SQL Server Authentication and launch as Territory 1 user. Then I'm going to drill into that database that we're working on and create a new query window. I'm going to paste those objects or those scripts. I'm going to begin a transaction because I don't want to commit anything here. And what I'm going to try to do is update the customer table, setting the first name to equal bad where territory ID is 2. Now, because I'm logged in as territory 1, you see that 0 rows are affected. This is that predicate that doesn't actually block you, but just filters the data out. The same thing for delete. If I try to delete those rows, I get 0 rows affected. And if I try to insert into that customer table and that last column is territory ID 6, it will not let me do that. Now this is the block predicate, which actually gives you the error message that you can handle in your application. So that here you're able to see a demonstration of both the block predicate and the filter predicate, and you can see that your application will have to handle that particular error. And it does have in the text block predicate, so the application can filter through the message and understand it, even with the message ID, level, state, and line number. Now if I return back, well, before I return back, I want to roll back this begin trend. If I go back and I try to do that as my DB owner user, you'll see that I can update where territory equals 2, I can delete where territory is 2, and I can insert where territory is 6. So that shows you the block and filter predicate on a particular user, territory 1, and then being able to do it as the DB owner of a table. Now to finish this, what I'm going to do is go ahead and drop all those objects so I can use it as another demonstration later on. This is a really quick but neat implementation of row level security. You can see we did something very, very simplistic, but once you get the hang of using row level security, you can make it more and more advanced for your application.